Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for zigzag conversion problem. Let's look at the problem description. We are given an input string and we have to return that string in a zigzag pattern on a given number of rows. And then we have to read row by row and return that as an output. Okay, so let's take a look at the example 1. So we are giving the input string as PayPal is hiring. We have to return in a zigzag pattern on 3 rows. PAY, PALISHIRING. Okay, and then we have to read left to right each row and generate the output. So in the case of example 2, it is written in a zigzag pattern on 4 rows. Okay, so the constraints are the string length is ranging from 1 to 1000 and the string contains only lower or uppercase letters and then comma and dot, and then the number of rows is ranging from 1 to 1000. Let's take a look at the approach to solve this problem. We are given this input string S, which is a PayPal is hiring, and we have to convert that into a zigzag pattern on 4 rows. Once that is converted, we have to read that zigzag pattern row by row and then generate the final output. We can solve this problem with the constant space. Okay, so in order to do that, we have to come up with an algorithm that computes the offset between the neighbor characters in the single array. Okay, for example, these two are neighbors, so the offset between these two is 6, and these two are neighbors, the offset between these two characters are 4. These two are neighbors, the offset between these two characters are 2. These 3 cases we have to handle. Okay, so if you notice, the offset between the pivot characters are 6, always 6. Okay, so between these two, 6, correct. So the first row and last row characters are all pivot characters. Okay, so whenever we process the first row and the last row, we have to add the sum of the vertical path character count and the diagonal path character count to the current index of this character. So this begins with 0. 0 plus 6 will point to this character. 6 plus 6, 12 point to this character. Okay, so for the first and last row, we have to simply add the number of characters in the vertical path and the number of characters in the diagonal path. Okay, this is pretty straightforward. But the tricky part is in this row, intermediate rows. Okay, so if you look at it, between this character, these two are neighbors, so the offset between those two characters is 4. In the same row, these two characters are neighbor, but the offset is 2, right? And between these two, the offset is 4. These two, the offset is 2. We can see a pattern here, right? It's alternating 4, 2, 4, 2. Similarly, in this row, you can see this character and this character is at offset 2. And this is at 4. This and this 2. And there is no more character. Okay, so 2, 4, 2. Here also we can see the pattern alternating. Okay, so when we move from a character in a vertical path to a character in a diagonal path, we have to use 4. If it is from a diagonal path to a vertical path, we have to add 2. But in the second row, from the vertical path to the diagonal path, it is 2. From the diagonal path to the vertical path, it is 4. It is exact opposite compared to the row 1, right? So we can come up with the formula in terms of the row index and the current character position, like whether it is in the vertical path or a diagonal path. Okay, so we can come up with the formula to compute the offset between the neighbors. That way we can direct, whenever we are in a particular index, we can compute the next index and then add that character to the output character without any intermediate space. Between these two, the distance is 4, and these two, the distance is 2. Basically, we have to process all the logical rows one by one. Whenever we process that logical row, depending on that row index, we can determine whether to use the offset 6 or 4 or 2. That's what I have listed here. So first we have to compute the maximum number of characters present in the vertical path and in the diagonal path. Okay, so the vertical path and then the diagonal path. Then compute the offset between the two characters that are closer and also change the path towards the same direction. I mean, that's what pivot characters 6. And then traverse the number of logical rows. Basically, these are all logical rows. They are not physically present because we are given a string. It is not a two-dimensional array. So that's why I call it as a logical row. And each row we traverse, first we initialize the current index with the row number. For example, if we are at row 0, the IDX is initialized with 0 so that the first character is read. And then we have to initialize the boolean called vertical that tells whether that current character is at the vertical path or the diagonal path. Then initialize the distance between the character in the vertical path and its neighbor in the current row. Depending on the row, the offset between the two neighbors vary. Okay. For example, if it is in the row 1, the offset between the first character and the second character is 4. But if it is in the row 2, offset between the first character and the second character is 2. That decreasing, right? And if you see here, the offset between these two characters is 6. 6, 4, 2. So gradually it is decreasing. So we can use that to compute the offset of the next character. For example, the maximum offset between the pivot minus row number times 2 will give the next character offset. Then I initialize the distance between the character and the diagonal path to its neighbor. Okay. Then traverse each character in a particular row. After processing the character, we have to toggle the vertical boolean so that we can indicate whether that next character is in the diagonal path or it is in the vertical path. Depending on that, the offset computation will be done. Then as we traverse, we keep adding it to the out array, and finally we convert that into a string and return it. Let's look at the flowchart. Input for this procedure is an input string yes and then the num rows. Okay. First we have to initialize the row index to 0 and then the count to the number of characters in the input string, and then the vertical character count, which is equal to the number of rows, and the diagonal character count, which is equal to number of rows minus 2, and then the pivot character offset, which is equal to the vertical character count plus the diagonal character count. Okay, So we have to initialize these things first, and then we enter the outer loop. There we check whether we processed all the rows. If not, then we go ahead and initialize the idx, which is the pointer that points to the next character to be read from the input string, and then the vertical boolean that indicates whether the current character is present at the vertical path or the diagonal path. And then another two variables, offset to diagonal character and then the offset to vertical character. So the offset to diagonal character is when the current character is in the vertical path and the next character will be in the diagonal path. So the offset between those two characters is computed by subtracting 2 times the row index from the pivot character offset. Okay, and next we compute the offset to vertical character when the current character is in the diagonal path and the next character will be in the vertical path. So the offset will be computed by subtracting the offset to diagonal character from the pivot character offset. These things needs to be initialized for each iteration of the outer loop. Once this is done, then we enter the inner loop where we traverse the logical row. Because that row is not physically present, what we have given is a single string. So we divide that as a into a logical row. We traverse the characters in the logical row. Okay. So first thing what we do is we read the character present at the idx in the input string and add it to the output array. Then we compute the next character's index by checking whether the current row is the first row or the last row. In those cases, all the characters are pivot characters, so they all differ by the pivot character offset. So the next character's index will be computed by adding the pivot character offset to the idx. Okay, this is for the first and last row. If it is an intermediate row, then we check whether the current character is in the vertical path. In that case, we have to add the offset to diagonal character to the index to compute the index of the next character in that row. Otherwise, we have to add the offset to vertical character because the current character is present in the diagonal path. Okay, so every iteration we compute the next character index for after reading the character, and then we toggle the boolean vertical to indicate whether the next character will be in the vertical path or diagonal path. Okay, so this inner loop continues until the idx is less than the maximum number of characters in the input string. Okay, then the moment the index is greater than the count, we come out of that inner loop and then go ahead and process the next logical row. Once all the rows are processed, then we come out and then we return the output string. Let's move on to coding. First, I initialize the count variable with the number of characters in the input string, and then initialize the out byte slice. Then I check whether the input string length is 1 or the number of rows is 1. In that case, we can return the input string as it is. Next, I initialize the vertical character count, which is equal to the number of rows. and then the diagonal character count, which is number of rows minus 2. Next I initialize the pivot character offset, which is equal to the vertical character count plus the diagonal character count. Next I write the outer for loop, which traverses all the logical rows in this. First I initialize the index with the row index. So the IDX is then pointed to the next character to be read from the input string, and then I initialize the vertical boolean to true to indicate the current character is in the vertical path, and then I compute the offset to diagonal character by subtracting r times 2 from the pivot character offset. Then I compute the offset to the vertical character by subtracting the offset to diagonal character from the pivot character offset. Then I write the inner for loop, which traverses the characters in that logical row. So this will run until the IDX is less than count. So first thing I do is read the character at IDX and add it to the output slice. Then I check whether the current row is the first row or the last row in the input. If so, I compute the index of the next character as by adding pivot character offset to the IDX. Otherwise, depending on whether it is in the whether the current character is in the vertical path, if the current character is in the vertical path, then I add the offset to the diagonal character to the index. Otherwise, I add the offset to the vertical character to the index. Once that is done, then I toggle the vertical boolean to indicate where the next character is present, whether it is in the vertical path or the diagonal path. Finally, I convert the out slice into a string and return it. Next, I am going to run the test cases. Okay, some compilation error. Okay, let me rerun the test case. All the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So the input string is the PayPal is hiring and the number is 4. Okay, so the zigzag pattern is like this, and the expected output is we read each row and then generate that string. Okay, so first we initialize the count variable to the number of characters in the input string, which is 14, and then initialize the output byte slice, which is empty, and then we check whether the count is equal to 1 or num rows is equal to 1. In that case, we have to return the input string. In this case, it is 14, so we are not returning, we are proceeding to initialize the vertical character count, which is the number of rows, and then the diagonal character count is 2 number of rows minus 2, which is equal to 2, and then we compute the offset between the pivot characters, these two characters or these two or these two. So it is 6. So this character is 6 characters away from this. Okay. Then we are entering the outer for loop. R is initialized to 0, and so in each iteration we initialize the index to the row index value. So in this case 0, so we assign 0 to the index. Okay. If you see the 0, we are processing the 0th row. So first we initialize this index of this character as the IDX. So that's what we are doing here. And once that is done, then we initialize the vertical boolean to true. So vertical boolean is true. And we compute the offset to diagonal character. Depending on the row, this value varies. So each time we have to compute this. Offset to diagonal character is equal to the pivot character offset minus the row index times 2. Okay. So in this case, the row index is 0. So the offset to diagonal character is 6. And then the offset to vertical character will be 0. But anyway, in the case of first and last row, we do not use these two variables in the offset calculation. Instead, we directly use the pivot character offset. Right. So then we enter the inner for loop. So we are entering the inner for loop, and first thing we do is read the character present at IDX and add it to the out. So P is at index 0, so we add that to the out array. Okay. Then we check whether we are processing the first row or the last row. In that case, we have to simply add the pivot character offset to the index to compute the neighbor. So the compute the index of this neighbor, we are simply adding the pivot character offset. Okay. So the next IDX will be 6. When we leave the iteration 0, inner loop iteration 0, the next index will be 6. So we will read the character present in that in the next iteration. So we are entering the iteration, and then one more thing we do is we toggle the vertical boolean, because the P is in the vertical path, its neighbor, I think in this case it doesn't matter because all are in the vertical path. Okay. So then we toggle the vertical boolean, and then we enter the next iteration where we read the character at index 6 and add it to the output, and then we compute the next index by adding the offset, by adding the pivot character offset to the current index, which is 6 plus 6, 12. Okay. And then the output will have P comma I. Then we enter the iteration 2. At that time we read the character at index 12. So PIN will be in the output, and then we toggle the vertical to, I think here it will be false. Okay. Then once that is done, we process the row 0. Next we enter, then we leave the outer loop iteration 0. Then we enter the outer loop iteration 1 where the row index is 1. So we initialize the IDX to 1 so that the second character will be red, and then we compute the offset to diagonal character by subtracting r times 2 from the pivot character offset. So in this case r is equal to 1. So pivot character offset is 6. 6 minus 2, 4. So when we are at row 1, the offset between these two is 4. 1, 2, 3, 4. Okay. And then we compute the offset to a vertical character by subtracting the diagonal character offset from the pivot character offset. So which is 6 minus 4, 2. So this offset is computed by subtracting the offset to diagonal character from the pivot character offset. So in the case of outer loop iteration 1, the offset to diagonal character is 4 and the offset to vertical character is 2. And we initialize the vertical boolean to true, and then we enter the inner loop where idx is less than count. So we go ahead and read the character at index 1 and add it to the output. Then we check whether we are in the we are processing the first row or last row. In this case it is the middle row. Then we check whether the current character is in the vertical path. If so, the next character index is computed by adding the offset to diagonal character. In this case it is 4. So 1 plus 4, 5. So the next character will be read from index 5, which is L. And then we toggle the vertical boolean to false, okay, to indicate that L next character is present in the diagonal path. Okay. So in the inner loop iteration 1, we read that character L and add it to the output. And then we compute the next character index by adding the offset to vertical character, because this L is present in the diagonal path. So we have to add the offset to vertical character to the index so that S will be added next. So 5 plus 2, 7. So the IDX will be updated with the value 7, and then we toggle the vertical to true, indicate the next character is present in the vertical path. Okay. So each inner loop iteration, the vertical boolean will be toggled so that it will indicate whether the character is present in the vertical path or diagonal path. Then we read the character from the index 7 and add it to the out list, and we then compute the next character's index by adding 4 because the current character is in the vertical path. So the next index will be 11. So the 11 will be added in the next iteration. So I is added. Because the current next character, the next character is present in the vertical path. So the offset added is 2. So the character present at index 13 will be added to the output. Then we complete the processing of the logical row 1. Okay. So similarly we process the rest of the zigzag path, and finally when we come to the iteration outer loop iteration 3, we have this output. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time and space complexity analysis for this input. So the time complexity is order of n because we have to traverse all the characters in this input string in order to generate the zigzag output. For example, in this case, the total number of characters is 14, and in row 0 we read 3 characters, and in row 1 we read 5 characters, in row 2 we read 4 characters, and in row 3 we read 2 characters. So totally 14 characters we read and add it to the output list. And also we do, so this piece of code runs 14 times. For the input string of length n, so we have to do n number of comparison and append operation. So the time complexity is order of n. With respect to the space complexity, we do not allocate any additional space to store the intermediate output. We directly read the next characters in the row from the input string. We are not using any intermediate list which stores all the elements in a particular row. We are just using few variables which are independent of the input size. So the space complexity is order of 1. Thanks for watching this video. Have a great day.